Many people assume that bringing advanced machine learning to the African continent is a simple matter of infrastructure and hardware distribution. We often imagine that the primary hurdle involves installing fiber optic cables or increasing energy capacity in remote regions. This perspective suggests that once the physical equipment exists, the software will integrate seamlessly into local life. However, this view ignores the underlying logic embedded within the code itself. We rarely question if the fundamental principles guiding these systems are compatible with the social structures they enter. This assumption overlooks a deep tension between existing design choices and local relational frameworks. Ubuntu is like a digital ecosystem map because it defines health through the density of mutual connections instead of isolated nodes. This framework suggests that a system remains incomplete if it focuses on solitary data points. When engineers build models, they frequently prioritize individual user interactions to maximize engagement metrics. This approach isolates information into silos, stripping away the context provided by family or community ties. If we apply this relational diagnostic, we identify technical errors in how algorithms process social information. Current models fail to recognize that human identity exists within a web of shared responsibilities. By shifting focus toward collective data sovereignty, developers might improve the accuracy of social predictions. These systems currently lack the capacity to process the weight of group history. Redesigning these architectures requires moving away from extraction toward a model that respects communal ownership of information. Technical success depends on acknowledging that every data point belongs to a broader lineage of human interaction. Consider a standard predictive tool designed to manage agricultural credit for small farmers. A typical system analyzes individual transaction history to determine loan eligibility. It ignores the fact that these farmers often pool resources to purchase seeds or equipment during harvest cycles. Because the algorithm treats each person as a standalone entity, it flags collaborative financial behavior as suspicious or inefficient. The software fails to account for the informal networks that keep these communities stable. It might deny a loan to a reliable individual simply because their personal account lacks consistent activity. This technical oversight creates a barrier for users whose economic reality relies on shared support. The system is accurate according to its own narrow logic, yet it is fundamentally flawed when placed in a real-world setting. A better approach would incorporate these collective patterns into the core training data. This change would allow the model to recognize the strength found in mutual assistance groups. My perspective shifts when I stop viewing traditional African ethics as a secondary cultural aesthetic. I now recognize these values as a rigorous method for evaluating technical failures in modern software development. We often treat ethics as a superficial layer added to a finished product, but this approach is insufficient. Instead, we should use these principles to audit the very foundation of how algorithms perceive human behavior. The current trend of prioritizing individual data extraction creates a distorted map of reality. It ignores the interconnected nature of human existence, which leads to systems that perform poorly in diverse social contexts. If developers adopt this diagnostic lens, they will find that many technical problems arise from a misunderstanding of social systems. We need to move toward a model where data sovereignty is held by the community, not just the corporation or the individual. This transition requires a complete change in how engineers define success metrics. Are we prepared to rebuild our digital architectures to reflect the reality of communal existence instead of just individual transactions? We have spent years assuming that technology is a neutral force that adapts to any environment. This belief has allowed us to ignore the biases built into the code we export globally. By re-examining our technical assumptions through a relational lens, we might find that the most advanced solutions are not always the most effective ones. The path forward requires a willingness to admit that current design methods are incomplete. What happens to our digital landscape when we begin to prioritize the health of our connections over the speed